Hello everyone, I am Prashant Kumar, pursuing BE at Sri Venkateswara College of Engineering, Bangalore. Today we are going to discuss about the topic Unguided Transmission Media in Computer Networks, subject code 21CS52. Now having a look through the table of contents where we are going to discuss about infrared transmission, microwave transmission, radio transmission, advantages and disadvantages of unguided media, wireless standards, Wi-Fi, Bluetooth, cellular networks, wireless interface, wireless network management, and finally the conclusion. Introduction. Unguided transmission media, also known as wireless media, is a type of communication channel that allows the transmission of data without the use of physical cables. It provides flexibility and mobility in network connections, enabling devices to communicate wirelessly. Examples of unguided transmission media include radio waves, microwaves, and infrared signals. Infrared transmission. Unguided infrared waves are widely used for short-range communication. The remote controls used for television, VCRs, and stereos all use infrared communication. They are relatively directional, cheap, and easy to build but have a major drawback. They do not pass through solid objects. Try standing between your remote control and your television and see if it still works. In general, as we go from long wave radio toward visible light, the waves behave more and more like light and less like radio. On the other hand, the fact that infrared waves do not pass through solid walls well is also a plus. It means that infrared system in one room of a building will not interfere with similar system in adjacent rooms or buildings. You cannot control your neighbor's television with your remote control. Furthermore, security of infrared systems against eavesdropping is better than the radio systems precisely for this reason. Therefore, no government license is needed to operate the infrared system, in contrast to radio systems, which must be licensed outside the ISM bands. Infrared communication has a limited use on the desktop. For example, to connect notebook computers and printers with IRDA standard, but it is not a major player in the communication game. Microwave transmission. Microwaves travel in straight line, so if the towers are too far apart, the earth will get in the way. Think about a Seattle to Amsterdam link. Thus repeaters are needed periodically. The higher the towers are, the further apart they can be. The distance between repeaters goes up very roughly with the square root of the tower height. For 100-meter high towers, repeaters can be 80 km apart. Unlike radio waves at lower frequency, microwaves do not pass through buildings well. In addition, even though the beam may be well focused at the transmitter, there is still some divergence in space. Some waves may be refracted off low-lying atmospheric layers and may take slightly longer to arrive than the direct waves. So the delayed waves may arrive out of the phase with direct wave and thus cancel the signal. This effect is called multipath fading and is often a serious problem. It is weather and the frequency dependent. Some operators keep 10% of their channels idle as spares to switch on when multipath fading temporarily wipes out some frequency band. The demand for more and more spectrum drives operators to yet higher frequencies. Bands up to 10 GHz are now in routine use, but at about 4 GHz a new problem sets in: absorption by water. These waves are only a few centimeters long and are absorbed by rain. This effect would be fine if one were planning to build a huge outdoor microwave oven for roasting passing birds, but for communication it is a severe problem. As with multipath fading, the only solution is to shut off links that are being rained on and route around them. Radio transmission. Radio frequency waves are easy to generate, can travel long distance and can penetrate buildings easily. So they are widely used for communication, both indoors and outdoors. Radio waves also are some omnidirectional, meaning that they travel in all directions from the source. So the transmitter and receiver do not have to be carefully aligned physically. Sometimes omnidirectional radio is good, but sometimes it is bad. In the 1970s, General Motors decided to equip all its new Cadillacs with computer-controlled anti-lock brakes. When the driver stepped on the brake pedal, the computer pulsed the brakes on and off instead of locking them on hard. On fine day, an Uyo highway patrolman began using his new mobile radio to call headquarters, and suddenly the Cadillac next to him began behaving like a bucking bronco. When the officer pulled the car over, the driver claimed that he had done nothing and the car had gone crazy. Eventually, a pattern began to emerge. Cadillacs would sometimes go berserk, but only on major highways in Ohio, and then only when the highway patrol was watching for a long time. General Motors could not understand why Cadillacs worked fine in all other states and also on minor roads in Ohio. Only after much searching did they discover that Cadillac's wiring made a fine antenna for the frequency used by the Ohio Highway Patrol's new radio system. The properties of radio waves are frequency department. At low frequency, radio waves pass through obstacles well, but the power falls off sharply with the distance from the source, at least as fast as half 1 by r2 in air as the signal energy spread more thinkingly over large surface. This attenuation is called path loss. Unguided transmission media advantages flexibility. Wireless connections allow devices to be mobile and communicate without physical constraints. Scalability. Unguided media can easily accommodate multiple devices and support network expansion. Cost effective. Wireless networks eliminate the need for extensive cabling infrastructure, reducing installation and maintenance costs. Disadvantages. Interference. Wireless signals can be affected by interference from other devices operating on the same frequency range. Limited bandwidth. The available bandwidth for wireless communication is limited compared to wired connections. Security. Wireless networks are more vulnerable to unauthorized access and data breaches compared to wired networks. Wireless standards. Various wireless standards have been developed to ensure compatibility and efficient communication between devices. Examples of wireless standards include IEEE 802.11, Wi-Fi, Bluetooth, and cellular network standards like 4G and 5G. Wireless standards define protocols, frequencies, and transmission techniques to ensure reliable and secure wireless communication. Wi-Fi. Wireless fidelity is a wireless networking technology based on IEEE 802.11 standards. It allows devices to connect to a local area network wirelessly, providing internet access and network resources. Wi-Fi operates in different frequency bands including 2.4 GHz and 5 GHz, offering various data transfer rates and coverage ranges. Bluetooth. Bluetooth is a wireless technology based for short-range communication between devices. It is commonly used for connecting peripherals such as keyboards, mice, and speakers to computer and smartphones. Bluetooth operates in the 2.4 GHz frequency band and provides low power, secure, and easy to use connections. Cellular networks. Cellular networks enable mobile communication by dividing geographic areas into cells served by base stations. They use licensed frequency bands to provide voice and data services to mobile phones. Cellular networks such as 4G and 5G offer high-speed data transfer, improved coverage, and low latency for mobile users, where each of the cells is assigned with multiple frequencies which corresponding radio base stations. The group of frequencies can be reused in other cells providing that the same frequency are not reused in adjacent neighboring cells as that would cause no channel interference. Wireless interference. Wireless signals can experience interference from various sources including other wireless devices, microwave, ovens, and physical barriers. Interference can degrade signal quality leading to decrease in network performance and reliability. Proper channel selection, signal strength optimization, and interference mitigation techniques can help minimize wireless interference. Wireless network management. Effective network management is essential for monitoring and maintaining wireless networks. It involves tasks such as device configuration, performance monitoring, security management, and troubleshooting. Network management tools and protocols like SNMP, Simple Network Management Protocol, are used to simplify and automate these tasks. Conclusion. In conclusion, unguided transmission media provides wireless connectivity in computer networks, enabling flexibility and mobility. Radio waves, microwaves, and infrared signals are examples of unguided transmission media. Proper network planning, security measures, and ongoing management are essential for efficient and reliable wireless network operation. Thank you.